Hola y bienvenido a Charla en la Oficina. Soy Nicole Simme y
I'm
nuestro
Simon.
nuevo invitado, Daniel. Okay, sorry. No, this is not a Spanish channel. Welcome to K6 Office Hours. I am Nicole van der Hoeven.
And I'm Simon.
Hey, I'm Daniel. I'm new to these office hours. I work as a site reliability engineer here at Key6. I love open source, reliability, all those things. And I also contribute to Grafana Tempo. I'm a maintainer, so yeah, I hope we can have some discussions.
Cool. It's so
And
great to have you here.
where do you live?
In Spain right now.
So like now maybe my intro makes a little more sense because I didn't just randomly do that. Okay. So Daniel, what exactly brought you to K6? Because I think you came
Ooh.
in through a different way than the rest of us, right?
Yeah, actually I interned at Key6 the last summer. I was looking for some internship in the site reliability engineering space, and I found Key6. I liked the product a lot. I think that is a really interesting product. I submitted an email, and now I'm here full time. So that's my path, I suppose. Yeah.
So you are on the DevOps team, back-end engineering. But I know that you've also made quite a few extensions for K6.
Ooh, yeah. Because yeah,
Want
I
to
have
demo
a,
any of them live?
probably not. Simme is the one that does those things. But yeah, I have created some extensions because I don't see Key6 like a load testing tool. I see it like a tool that I can customize to do a lot of things related with reliability, from chaos engineering to integration testing to whatever. So yeah, I have brought some extensions about multiple different things that I needed. I have to say that the process is really straightforward from my point of view.
Because you are, just to add some more information about you, Daniel, you are, or at least used to be, one of the key contributors to Bloomberg's chaos engineering product, Powerful Seal. Or at least that's how I interpreted it as an outsider looking at the commit log in that project. So you have quite a bit of experience with chaos engineering as well, I would say.
Yeah, maybe not a core contributor because I didn't have any power or decision making. I mean, in the process, but yeah, I contributed it while I was at university. I think that it's a really interesting project. Yeah, I think it works really well. So I have some experience doing chaos engineering, but we're doing more things internally at Kixi, so I am gaining more practical experience about that. I had some theoretical experience, but not that much about practical things.
So I think today, this week at least, we wanted to talk about chaos engineering in general and then in specific, because I think Simme wants to demo something for us. The thing is, like, out of this group in particular, I am definitely the chaos engineering noob here. I know about it in theory. So I'm going to be asking questions to maybe both of you or whoever wants to answer. But Simme, you want to kind of talk a bit about what chaos engineering even is?
Sure, I thought you were going to say that you were the expert among us.
Maybe.
But
No.
I can definitely do that. So chaos engineering, chaos engineering is basically the practice where you introduce some kind of turbulence in a controlled behavior in your environment. So, and then measure what happens once you're hit by that turbulence. And you do this with a scientific approach where you form some kind of hypothesis that explains, or rather makes a statement about your environment. For instance, once this happens, we expect this to be the result of that or the outcome of that. And then you try that either in production or in a test environment, depending on how mature your chaos engineering processes are. And you just want to build confidence around your product and that it actually behaves as you think it will when you experience turbulence that you're not in control of.
So here's my, sorry, go on.
I was just going to say that a lot of people might think of chaos engineering as this mad scientist who just wreaks havoc in an environment and then just sees whatever does not burn when you're done, and points at that and says, okay, so that one is probably stable. But that's not actually how the practice works. It's really, really controlled, and we try to do it in a very conscious and careful manner where we try to make the impact as little as possible and expand from that initial hypothesis we formulate around the system or its reliability.
Also, I want to add something, and it's that some people just think, yeah, I'm going to just engineer some service, right? But it's not like that, because some people don't even know if the service is behaving like normally, if it's reliable, if this service works well in the continuum of time, and they just start breaking things and seeing things up. From my point of view, if you have these, for example, these service level indicators and objectives, and you can measure how this service is performing, you can spend the extra budget on these efforts. I think that this is something important to keep in mind.
So here's my maybe controversial question. Would you say that chaos engineering is actually an approach to testing? Because I know that chaos engineering principles, they are very careful not to use testing terminology. It's all in terms of the scientific method and experimentation, and basically making it more scientific. But it seems to me that at the end of the day, testing and chaos engineering have the same goal, which is improving the quality of applications.
Yeah, I think you're onto something there. It is a controversial opinion, and I think it makes sense to make the distinction, because we want to use a new terminology because that will remind us of the difference in approach, right? So if we were to use the old testing methodology or the classic testing, I'm not going to say old, then we might get forced into old habits where we test or we experiment in a way that makes sense from a testing methodology perspective. But we want to, disrupt this and do it in another way that we believe will add more value and will build confidence around things we don't know rather than proving things we already know. So I think you are right in what you're saying, but I also think it makes sense to make the distinction, despite that fact.
Because the way that I was thinking about it is, I agree that there's a very different approach. There's a different attitude, really, with chaos engineering compared to a typical attitude for testing. But I actually think that testing should evolve to maybe incorporate some of these aspects. Maybe we should talk about like the process of chaos engineering, because it's pretty substantially different from typical testing approaches.
Absolutely. And when it comes to chaos engineering or doing a chaos engineering experiment, or maybe actually executing something, you usually divide that into a couple of different steps. First, you try to come up with a hypothesis, or you try to define the steady state of your application, just as Daniel mentioned as well. You want to know what does my application look like when it's under normal operations? What's the normal state of my application? We have the normal amount of users, we have the normal amount of load, and how does my system look then? And we want to use that as a baseline and try to make that a prerequisite for actually running any chaos experiment in our environment. Because if our environment is already under heavy stress, then it makes no sense to apply even more stress to it. But once we've done that, we've defined the steady state of our application or our system, then we want to go ahead and formulate a hypothesis around our system that will let us know whether the system is actually behaving in the way that we expected. For instance, it could be something along the lines of when one of my web server API endpoints, or one of my web workers, when that one is killed unexpectedly or terminated, maybe it's a better term, then I want business to be continued as usual. I don't want to have any rejected requests due to that. So then we formulate a positive hypothesis around that, where the goal is to prove that it actually is the way that we expected, right? So it will work. That's the target for the experiment. And then we create an experiment that takes this turbulence that we formulated in our hypotheses and applies that to our service, and we measure the outcome and see whether we were right in our assumption, or whether we need to do any additional patches or whatever, or changes to make sure that it will endure through this turbulence that we've set loose on it. So because that's kind of vital as well, I think, to make sure that the experiment or the hypothesis that you're building your experiment from, you should actually believe that it will work. Because if you are already skeptic, or you think that it will fail, then it really doesn't make any sense to go for a chaos experiment. You should probably have a look at those things you suspect might interrupt your service first before you get started with your experiment. And then you just repeat that cycle over and over again.
So far, it seems like best practices for load testing as well, because I think that a lot of people who get into load testing for the first time, or a lot of teams or companies, they go directly into running a full peak load test, but they don't actually know what the steady state for their application even is. So I think that it's very difficult to draw any conclusions if you don't have a control group to compare it to, because maybe when you have a load test, maybe the response time, increases. But actually, how do you know that it increased if you weren't measuring it before?
It's kind of a buzzword from my point of view, but here's where observability comes into play. I mean, your ability to ask questions about how the system is behaving like I will expect or not. Actually, I think that some companies try to start doing performance testing or testing or chaos engineering without having this stack of tools that they can use to answer a question, these logs, these metrics, even distributed tracing if you are more in deep. But yeah,
So when it comes to the steady state, what are some things that you think we should be looking out for? Like, what specific metrics would you be looking at?
depends. For example, if your org is following the site reliability principles, probably it's enough to look at the service level indicators, because you already defined what it's reliable. I mean, what means for this service to be reliable or not with the objectives. If you don't have that, you can check the common things for each service. If it's request based, you can check latency, you can check throughput, you can check the common things, availability. But yeah, just depends on how you call these things, but it's the same, I would say.
Okay, so when you're starting, ideally you would have had some period of time with it too. It's not just a snapshot, right? You would have wanted ideally historical records going back as far as possible, just to see where things are. Is that right?
Yeah, that could make sense, but you could also say that, okay, right now the service is behaving as we expect it to. We're going to use that as our baseline. If you don't have access to any historical data, or if you, for instance, think that the historical data might be overkill to analyze and draw any conclusions from, then you could, of course, just go for an immediate snapshot. That would work just as well. You probably have to redo that snapshot at some point once you start to get improvements. But it would definitely serve well as a starting point. I mean, you'll probably increase the performance and increase the reliability of your service quite a lot, quite fast. So maybe it's enough to just have something to get you started, something that you can use as your initial baseline.
Okay, and how do you both think that load testing would fit into this? Are they separate activities? Does one affect the other? Should one come before the other?
I think that both should be friends. I mean, I don't think that you can do. I don't think that you can do chaos engineering without faking some load. Or well, if you are running production, you can create this subgroup, right? But probably you want to generate some load for something. Maybe you want to stress this database. So what's going to happen, right? This hypothesis, all these things. I don't know what Simme thinks, but I think that both should be like together from my point of view.
Yeah, I think so as well. I mean, a test in a staging environment that does not have any load whatsoever, that's going to be a pretty bad test or experiment, because that will never be the case in your production environment. You will hopefully at least never have 0 users that are doing 0 things. So because then you don't even have to do any chaos experiments, because it won't impact any users because you don't have any users. So it definitely makes sense to apply some kind of load towards your service while doing chaos experiments, or for that instance to actually use the load as your turbulence, because that is also and probably the more realistic, or the more common approach that we'd use while doing actual load testing, that we see the load as the anomaly in the system, and the one that we want to make sure that we can swallow, or that we can withstand. But just having some at least baseline traffic, or the traffic you would have in your normal production environment, running through your test system or your staging system while you're performing the experiments, definitely makes sense.
And sometimes, even if you want to run the testing, sorry, Nicole.
No, go.
Even if you're running in production, maybe you are right now, there is no the load that you want to test. I mean, maybe you want to do some hypothesis over some type of load, right, that you are not having right now. So you can fake that in production with other things. So that's quite interesting.
Yeah.
So here's what I'm thinking, and please correct me if my understanding's not correct. I think that in the same way that I don't think it's a good idea to load test before functional testing has been done, because you might get really like breaking functional defects that are going to stop your load testing anyway. It doesn't make sense if you can't even go to end to end. I kind of have this idea that load testing, or at least the general phase of load testing, should have been done before chaos engineering, because if chaos engineering requires any load, if there's already a problem with the application handling that load, then what's the point in adding more complexity to it when you know it fails before then?
Because sometimes it's not about load. Sometimes you are going to run, for example, a chaos experiment just to test that your team can handle that incident, that they can troubleshoot what's happening. It's really useful to create that kind of case, right? Where maybe that database goes down. Who knows what is going to happen, right? Can we fix that state? Can we recover from it? I fully agree with you that probably if the service is going to crash with some normal loads of some loads, maybe it's not interesting to add more things to it. But I don't know. I think that this concept, this framework of chaos engineering can be used for a lot of things. So you can apply it to what matters to you from my point of view.
I agree. And I'm thinking that maybe, I know, for instance, the Chaos Toolkit, they are trying to assign some kind of value to each experiment, in what way they increase the confidence in your system. For instance, this test will increase your confidence in scalability. This test experiment will increase your confidence in your ability to withstand security issues, for instance. And if you have this segmentation of what they will contribute with, then maybe for the ones that concern scalability, one of the criteria for the steady state hypothesis should probably be that it should be able to endure normal load. And if it doesn't, we would probably abort the experiment prematurely.
Okay, so it sounds like there are some chaos experiments that can occur in parallel with load testing activities, but some things are dependent.
Yeah. For example, this is a real use case, something that I'm doing here internally at K6. I'm using chaos engineering and load testing at the same time to test if observability, I mean, if the metrics that we have are working, right? Because it's something that maybe you think that it's going to work by default, but maybe not, right? Maybe you are not measuring what you want to measure. And you can do this kind of, even if the service is just moving from staging to production, you can do this to check if the things are measuring what matters and in the correct way. It's something like that.
Yeah, and also
Okay.
if you, for instance, if you were to do observability or distributed tracing for that matter with some load, that would be really interesting as well to be able to see, for instance, okay, is our data retention configured correctly? That could be a peripheral use case for it. So okay, if we have 10,000 users hammering against our or ordering service, for instance, will we still keep the traces the sufficient amount of time, or will they get rotated out of our logs or rotated out of our observability platform before we have a chance to troubleshoot or to actually trace what has happened in that particular transaction or that particular aggregate route?
Okay, so far, let's run through the process. So we've defined the steady state, which ideally we would have obtained through some sort of observability platform to get the metrics that we need. We need a stable environment, at least one where there aren't some crazy breaking bugs or something that would stop us. Basically, something that would make it silly to continue to add more complexity. We build a hypothesis, so something like when an instance is shut down, the application recovers and switches to another node within 10 minutes. And then after that, and we've set the abort conditions and the blast radius, so like what components are we trying to target, and ideally set it as small as possible. How do we actually execute the experiments then?
We can do that in a variety of ways. There are multiple tools available for doing that. You could, for instance, use Gremlin, which is a SaaS product for doing exactly that. Or you could use Chaos Toolkit, or for that instance, Powerful Seal, which does that as well. Or you could use XK6 Chaos. So you have a lot of different tools to choose from, but what they all have in common is that they, in some way, get almost administrative privileges to your cluster, so they'd be able to create all these turbulent conditions. You might, of course, scale this down, but they're going to need to have some permissions to be able to, for instance, launch a new node that eats CPU, or add a proxy to a pod to make sure that the latency grows, or for that instance, killing a pod, which a normal user hopefully is not able to do in your cluster. So some kind of way of interacting with your actual environment. It doesn't have to be a tool or a framework. You could, for instance, do your chaos engineering manually by using bash scripts, for instance. That works just as well as if you have that practice down. But for most of us, at least for most of us that are starting out with chaos engineering, it usually makes sense to pick a tool and try to use that to not have to reinvent the wheel and account for all the edge cases that you would get if you were to write it from scratch yourself.
And it's for repeatability as well, right? Because I might do a very different test from what you would do, and we might both call that shutting down a node.
Mm-hmm.
Yeah,
I might have a completely different hypothesis to you.
And as Simme says, for sharing knowledge, I mean, if I'm going to kill some Kubernetes pod, why I have to rewrite this, right? Maybe I can just use some tool that can do this. We're all doing this, right? So this is pretty cool.
And I think that goes for almost all quality efforts when we build software. We should try to stand on the shoulder of giants, or try to learn from others that have done the same things before us, because there is no need, or there is no use to actually trying to or believing that you can invent something that's better than what a lot of people have already put a lot of effort into. In some cases you can do that. You could totally disrupt the field, for instance, by starting doing chaos engineering back in the day before it was a thing. But for most of us that want to take a practice and just reap the benefits we get from that, it usually doesn't make sense to start from scratch, and I think we can do a better job, but rather try to leverage that someone has been there before us and try to apply all their knowledge to it.
Okay, so what are you sharing with us today? Which tool?
Okay, so what I'm going to share today, surprise, is a proof of concept that I'm working on for K6, where we'd be able to interact with a Kubernetes cluster directly from K6 and do some chaos experiments on that cluster. And for those of you who haven't used XK6 previously, XK6 is a custom way of building K6 binaries that include whatever extension that you feel that you would need to get the most value out of the product. So as Daniel says, K6, I don't really either see it as a pure load testing tool. It's rather a really great platform to work with reliability and with resilience in general, whether it's load or if it's other performance issues, scaling, security. All of these things are perfectly possible to do in K6. So I just see it as the blank canvas that I draw whatever I need to test. And in this particular case, we're going to do it with an extension called XK6 Chaos that I'm writing, as well as a notification service that Daniel has written for actually serving notifications to Slack, for instance, or to an email or whatever notification method you prefer. So I'm going to go ahead and share my screen.
And then Daniel will share his screen and demo his extension.
My extensions are not yours to use. Please don't use them for nothing important yet.
Okay, so I've actually gone ahead and written this script already. So in this particular case, let me just fire up a terminal as well.
Simme, that's not a secret, right?
This one? No, that one will not work as soon as this demo is over.
Okay.
So no worries. You don't even have to try that. I will find you.
We are chaos engineering security here. As you can see.
So we have a cluster prepared with a lot of Nginx servers that are serving the name of that particular pod when you curl their HTTP endpoint. So you can curl it and it will load balance between these different pods, and you will get back which pod you arrived at. Right? So far, so good, right? So what we want to do here is that we want to set up a load test with two different scenarios running. We want one scenario that is going to add some turbulence to our load test. And then we want just a regular load test that will keep hammering this service with 100 VUs for 2 minutes. So every 10 seconds, we will kill off one of the pods in this cluster. Wow, that was a large picture of me.
Sorry, I was trying to like show just you and the screen. Sorry, don't mind me. We are
Yes.
pros giving away Slack secrets.
What a demo, right? What a demo.
So after 10 seconds of just ramping up the load test, then we're going to start doing these turbulence injections. So with a 10-second interval, we're going to kill off one of the pods and then continue to apply this load and make sure that we still get the result that we're looking for. So what I've done is that I've prepared a XK6 binary. We can have a look at that as well. It's really easy to use. So you just download the XK6 tool, and then you XK6 build, and then you supply -- with, followed by the package that you want to add. So I've added Daniel's XK6 notification package, as well as the XK6 chaos package. And what we get out of that is a bespoke K6 binary that we can use with those packages, right? So I've actually imported these packages here, as you can see. I'm importing the chaos module and the pods class from that module, as well as the notification service. And then we go ahead in our default function, which is the actual load test. We just pull this endpoint, just as I showed you with curl, and we make sure that it continues to reply with 200 as the status code. We're going to use the notification service or the notification module to send a Slack notification that will let us know that a chaos experiment has started, and that we should be careful to not, or we should be aware of that, so we don't do any production, emergency procedures that might be uncalled for given the circumstance. So we do that when we start a test. We then start running the default function and apply load at our load to our service, and then every 10 seconds we're just gonna get a random pod from the namespace, the chaos demo namespace actually. So I'm just gonna go ahead and change that.
So, sorry, just a question.
Yeah.
I haven't personally used the notifications extension yet. Is that specifically for use with XK6 Chaos, or is it just notifications on load tests in general? How does that work?
Yeah, it's actually XK6 notifications is a separate package that you can use standalone with XK6. You can't use it with regular K6 yet, at least, but it's available to include in your XK6 binary, and it will use the open source project Shouter to allow you to use any of the notification services available there. So you can, for instance, use Mattermost or Discord or Slack or email or Telegram. So you can integrate it with whatever you
Telegram.
Yeah, Telegram as well.
Yeah, works with a lot of things.
Yeah.
Oh no, you
I
have
think
my number
Simme
now.
has some relation with that project.
And usually when I talk about Shouter, I kind of want to mention Apprise as well, which is a Python version, or rather the original version of Shouter, the project that we've been inspired by to write Shouter in Go. So if you want a real huge list of services and a stable API or stable package that's been around for ages, then you could use Apprise. But Shouter is in Go as compared to Python, so it works really good with Go applications. So that's what we were using in this case. So we start the experiment and let everyone know that we're running an experiment. We then apply our load, and every 10 seconds we choose a random pod from our chaos demo namespace. That is the pods we were seeing here. And we just kill that. and continue with our load. And then we repeat this process every 10 seconds until 1 minute has passed. And then we run for another additional minute with just load to make sure that we still don't get any errors. And that's basically all there is to it. So if the demo gods allow, I will now try to show you this. So we run this. And as you can see, it's crunching away, doing quite a lot of iterations. And now it's doing the first iteration of turbulence injection. So it killed off the 49.2cc pod.
So is this actually posting somewhere in our Slack? I want to see as well.
It is. Let me show that as well.
It might be a channel I'm not a part of, honestly.
Probably. I think we can invite you. Let me. Okay, here you go.
Okay. Chaos experiment started by Simme, 5:36 p.m. Was that? Yeah. Wow, cool. It's a real demo.
K6 is not working. Simme, what are you doing?
Why?
Cloud is down or not? What are you breaking?
Okay, so now the actual turbulence part of the test is done. So now we will just continue to apply some load for a couple of seconds more, about 30 seconds more. And then we will let everyone in the Slack know that the test is over. So I'm going to share a screenshot of that as soon as we're done with the test. So you can see how that will look like.
It's really interesting because I have done things like this with K6, but I follow a different approach. It's really interesting to see your approach to these things. For example, when I do these tests, usually I create some scenario that is going to check the steady state of the system. So that scenario starts, and then sometime later, I start ingesting, putting some load, right? And I check that the steady state is steady, right? And I continue adding load. And then at some time, I start injecting failures. For example, I developed one extension for launching jobs in Kubernetes. So you can, for example, stress some node, all the CPU or all the memory. And I play with that steady state. So yeah, just different approaches to the same problem. Just I thought that it was curious to share.
Yeah, and I think probably the approach that you're following, that's the one that I would also use in a real world scenario where we have to make sure that we don't destroy anything. In this case, this is actually my home server. It stands here just half a meter away, so it can break all at once. So I didn't bother with adding a steady state hypothesis to this. Although I did add the 10-second delay before the first injection. So in case we would get any like really obvious errors, then it would already fail at that point. So we wouldn't even continue with the actual failure injection. But this is how it would look like. You get a notification, chaos experiment started by Simme, watch out. And whenever you run a chaos experiment using K6, then beware, Nicole will join your channel.
It's like chaos experiment? Where?
so make sure you don't post your experiment notifications in any secret channel, because Nicole will be there.
It's sneaking into yours.
Chaos magnet.
And then once the test was over, we got a new notification saying that it's over. So I think this code approach to chaos engineering that I've not seen in any other tool so far, this is quite unique to K6, and it really shows the strength you have with being able to script using JavaScript. So you could, for instance, okay, so nothing went down, then I'm going to scale up my attempts. I'm going to add more turbulence. Or, okay, I'm seeing some degradation. Maybe I should scale down, because now we already know that. And this is something that will introduce some kind of degradation to our system.
And you
Yeah.
have a power that you don't have with YAML or with some other language
Yeah.
that you might use, right? Here, if I want to do something, I can add a new extension in Go. We all know that the common ops tools that everyone is using have Go clients these days, right? So it's pretty easy to just add something that I want.
Mm.
So in this case, Simme, you made it randomly shut down one node. Is that right? Pod.
Yes. Yes.
Can you kind of change it to say, first shut down one pod, wait 10 minutes, then shut down another, or something like that?
Yeah, absolutely. And this is just how I set it up. If we have a look at the code again, you can see that I'm listing pods that are within a namespace. And then I'm just choosing the first in that list, and I'm killing off that pod. So you could add whatever JavaScript code you have, or additional logic to that. For instance, say that, okay, I want to do some pattern matching on the name. I want to kill off all pods that start with an A, because I really hate the letter A. And then you could do that using regular JavaScript, and then you would just
Sorry,
feed that
Artem.
to
And Anna from our team.
yeah. And then you could just feed that to the kill by name function instead. So definitely you can do all sorts of crazy things. It's still a very early alpha. It's probably like 10 hours of work into this or something like that. So I would love for all the feedback you can give on it. So if you go to our GitHub page, K6IO, or rather if you go to my GitHub page, Simskij, or SIMSKIJ, yeah, then you'll find the XK6 Chaos repository there. And I'd love for you to try it out and let me know what you think works and what you think is missing, or anything you would have done differently, so we can continue to elaborate on this tool. Because I really believe that this will be a really powerful complementary chaos testing product once we get a little further with the development. But yeah, that was basically what I was going to show. It shows notifications and it shows XK6 chaos. So these are all things that I've built with the built-in support for extensions in K6.
I wanted to add that if someone wants to look like at the available extensions that we have right now, there is a GitHub tag, and you can surf all the extensions, at least the ones that are tagged right now. I send it in the chat.
I also posted the link to your extension, Simme, in the
Great.
chat.
Thanks.
So I did want to ask. Oh, sorry, go on.
No, I mean, all the extensions are proof of concepts. I don't think anyone is using these extensions like very seriously right now. We're still toying with them and trying to do some useful things. But yeah, if the people have some time, I would love if people can take a look at them. Yeah, it was.
But I mean, you two are playing it down as the authors of these extensions, but it actually already works. Yes, you'd like to maybe extend and add different types of experiments, but for what you wanted it to do, it already works. So kudos to both of you.
Virtual high fives. Yeah.
Yeah, it doesn't really work well. But I did want to ask Simme. I was asking you whether I should start with XK6 Chaos or a Chaos Toolkit, and you said XK6 Chaos is more fun. Why?
Yeah, I think it's more fun because I've written it, right? So that, that's probably the reason. But also because I think in general, K6 is quite fun. It's fun to work with since you are able to script and you have all this freedom that you don't get in most other tools. So from that perspective, I'd say that using XK6 Chaos is probably more fun than some other tools because you're able to really customize or tailor the experiments that you're doing to what you want to achieve. But I'm biased since I'm writing it. So of course I'm going to think that it's more fun, but that might not be true for everyone. And in most cases, maybe fun is not the main thing that you're measured by. So you probably want to do what gives you the most value. And at this point, I wouldn't say that that's XK6 Chaos. That's probably one of the other tools that have had a lot more of development gone into making them solid.
Yep, but I would say that it's fun because we're using a real programming language. I suppose if you like to program and to build the things that you need, you can do that easily. I mean, if you want to destroy some digital ocean droplets, you can pick the Golang library, put some extension in like 15 minutes and have something working in K6. Other tools that are closed source, or well, the ones that are open source, from my point of view, are not that straightforward to extend. JavaScript toolkit is really good on that aspect, but not all the tools are that extendable and that
And it's
easy.
YAML, isn't it?
It's YAML, so
Yeah.
you have different constraints, I suppose. You have to specify
Yeah.
which values to use and those things. But yeah.
So what would you like to add, Simme? Like, if you had the time to develop this further, what would you add next?
I saw Daniel's proof of concept the other day, which I think was really, really impressive. I would like to add that as a canned experiment to the Chaos module.
Which one is
well.
this?
This was starving a node of CPU resources. So you would spin up a pod and have that eat all available CPU, and look what would happen to the system that is actually supposed to be running on that node.
And actually, I was using this for something real, so it was funnier. I think it's a really interesting scenario. Something we should maybe polish and showcase some other day.
So what do you do to eat up the CPU?
I developed this strange extension that lets you send jobs to Kubernetes. Jobs are like pods, but they're like for something that we want just to launch on demand, and it's not going to run forever. I use, I'm not sure how it's called, but there is one Docker container that ships with a lot of stress tools for CPU, memory, all those things. So I just use my extension, put the right things that I want to use at the startup on the Docker container, and that was all, right? The other things are just things to improve the experiment, but the failure was just that. It was really straightforward from my point of view.
And
Could you do the
assume
same thing for memory?
What?
Could you do the same thing for memory?
Yeah, for both things. The things that probably is more problematic is network. Network is a different topic. But if you want just to source resources in some node, it should be straightforward to use. Yeah. But if I would say what's K6 missing right now so you can do chaos engineering properly, like one thing, I would say that it's like having the tools to better inspect the steady state. Because right now we're seeing the system from the outside, right? We're generating some load and we can see that. But we can't query Prometheus, or we can, query some other internal systems that probably know better about your steady state. I have been toying with these ideas, but it's something that probably needs a lot of thought on how to do it properly. I think it's something that probably K6 is missing right now.
Yeah, and being able to read out or to list metrics from, say, Prometheus, as you said, with a Prometheus client wrapper, and then be able to even formulate thresholds against those metrics. That would be really powerful.
Using external metrics as native K6 metrics, I think that would be like a really cool feature. Even in K6 Cloud, adding something like that, where you can see these metrics from other places. I don't know. I like that idea a lot.
And
as a tester, go on.
Sorry, as you might get, Daniel and I, we speak a lot about these things, about different kind of extensions and chaos things that we could add. So we're really excited to develop this project and to both XK6 in general and XK6 Chaos and the Kubernetes extensions, all of that. So if you want to get started or if you want to contribute in some way, just get in touch with us, either on the community Slack or on Twitter or wherever you find us, because we'd be more than happy to onboard you and have you contribute in a way that feels meaningful to you. So all contributors are welcome. You don't have to be an expert in any of the topics, because we sure are not.
Just discussing these things is just contributing. You don't have to ask talks or anything, just sharing what would you like to do with K6, or like how will your perfect tool will work, like those things are enough from my point of view.
I was just going to say that as a tester, I think one of the reasons I'm drawn to using something like XK6 Chaos is that I don't have to learn a new tool. It's just an extension to K6, which I'm already using. So I really love the idea of like already being able to use K6 as like a functional API testing tool, and then turning the same script into a load test, and then adding a chaos experiment, all with one tool. Like that's what I like. That's, I think, the most powerful feature reason to go for something like XK6 Chaos.
It's like Terraform from my point of view. I mean, with Terraform you can use all kinds of providers for all the weird things that you want, and you can have everything with one tool, and that's really, really interesting.
I think it's all about kind of distilling things down to what's really important and then modularizing them. I mean, I think that's the theory behind like containers in general, right? And virtual servers before that. I think it's just an extension that if you have one tool that can do all of these separate modules, and then you can compile them, you can build it into one tool at runtime depending on what your needs are. I think that's the dream.
Yeah, it's kind of like a Swiss Army knife, but you're able to switch out whatever tools you have in it. So if you want for instance, a wheelbarrow, then you can add a wheelbarrow to your Swiss Army knife. It would be a little impractical maybe because it's huge, but you have that flexibility.
Right. For you, it's going to work, and that's really cool.
Yeah.
So, okay, let's have a thought experiment. Let's say we need to do chaos days at K6 regularly. What are your first few steps?
Actually, we are starting to do something like this with some internal transition that we are starting to do. Each service that we are migrating, we are doing just some small chaos experiments to understand more about the service. We're not trying to do some reliability stuff. We're just trying to understand how the system behaves in different situations. So a good start is just that. Don't use chaos engineering just for breaking things or just to deepen your knowledge of your systems. I think that maybe is like the first step if you want to start using these things.
And then what?
Simme, continue, please.
And then break things. No. But I think you're onto something there, Daniel, that it's the goal is not to cause as much havoc as possible in your environment. The goal is to start with something that you don't know. For instance, how would this system behave under a certain condition? And you want to test that so that you know how it behaves. Hopefully it behaves just as you expect it to. But if it doesn't, then you'll have a really good opportunity to fix that. And then you kind of just grow that perimeter into different areas, and you just repeat the same steps. It doesn't have to be dramatic. You don't have to uproot every process you have. You can just start small, start in an edge, and work yourself into your environment in bigger and bigger circles.
There is one problem that we didn't mention, but once you start with this circle, once you start like injecting failures, you are going to have like a lot of work because maybe your maybe your incident response system maybe doesn't scale with the things that you are trying to do. Maybe the setup, your dashboards are not great, or maybe you are not measuring the right things. So once you start with this process, there are like a lot of projects that are going to come up, right? Things that we can improve so our systems can behave better and our users are happy. So I suppose everything is related.
Yeah, and I think that's a good point, because what you're doing if you follow that approach is that you're taking whatever effort you would have to put into uh, making your systems behave at nights and during weekends and when you are celebrating Christmas or on vacation, and you'd have to go in and fix things in your environment. You're basically moving that to office hours when you're already in the office working and when you are in control of what is
Mhm.
happening. And I think that is one of the major points of why I think that it makes so much sense to do chaos engineering, because I hate being woken up by pager duty in the middle of the night and having to go on call and fix all of these weird bugs while I probably don't even know my name or where I am. So I'd much rather be able to do that while I am working, while I'm working scheduled hours, uh, and then be able to opt out of having to even do incident response cycles at night or in weekends.
Sometimes things are going to fail, right? And that's
Yeah.
okay. That's expected. You can't scale to the end, right? But it's useful to have these game days, for example, monthly, weekly, depends on your organization, depends on a lot of things. So your developers can train how to react on the
Mm.
incidents. Because if you only have real incidents, your developers probably are going to forget where the dashboard is or how to use the tooling to debug the problem, right? So if you have this continuous feedback, this continuous game days, you can improve your checklist, you can improve your run books, you can improve all this tooling continuously, and everyone is familiar with it. So everyone can debug those problems and work on things.
And just to tie back on Nicole's question regarding what you should start with, I would probably say start with making sure that you have a disaster recovery plan. Start with making sure that you even have an incident management process in place, because those are probably the most vital things. They will probably change a lot and change a lot very early in your chaos engineering efforts. But having them in place so you know what to do, for instance, if you happen to crash the database server and is unable to get it up, who should you call? Who will be available? And things like that. That really gives you another level of confidence that you probably want to have when you run these experiments. Because systems are fragile, at least if you've not put any effort into making them non-fragile. So having those processes and routines nailed before you get started is probably a good idea for most.
And I think that's one of the main differences between chaos engineering and the traditional testing approach is because as a tester, you're taught to think in terms of will I find this defect or does this defect exist? Does this functionality work? But chaos engineering is more things are going to happen. You're going to encounter failure. There will be an outage. How do you deal with it? How do you prepare for it?
Also, I think it's pretty related, chaos engineering, with these reliability concepts and this mindset
Mhm.
where it's okay if things fail because we don't want this 100% reliability in our services. That's impossible, right? We can't assure that. So we have some reasonable thresholds, right, that our objectives define. And it's okay if the service is down for 1 minute this month, right? It just depends on what you expect from each service. And I suppose that's a difference too, like on performance, like you are trying to find these things. So yeah.
Yeah, and the concept of diminishing returns is very much applicable to reliability as well. I mean, there is a reason why I would say why none of the major cloud providers, for instance, even offer 100% uptime, because aiming or even having 100% uptime, if it were possible, which I also don't think it is, but even if it was possible, then it would be so freaking expensive that no one would be able to afford that service anyway. So finding that reasonable spot, maybe 99.9 or 5 nines or whatever is your desired level, maybe that's the point to stop and say that, okay, we're satisfied with this.
Keep in
Or
mind
even
that-
lower for many companies.
Keep in mind that you can keep this reliability high if you don't ship new features. So if you ship new features, you should have like a lower threshold for it. Depends, right? But about the 100% reliability, I think it's really interesting because your internet provider doesn't have that reliability. So who cares what Google is doing, right? You won't get that availability. So yeah, it's just things.
And it doesn't
And
really
also-
matter if the server is up and running if no one can access it because the internet connection is down.
Yeah.
Yeah.
And we're not all Googles and Amazons, right? Okay,
No.
well, thank you. Thank you for joining us, Daniel. You should come onto office hours more in the future.
If you invite me, maybe.
You're always invited. All right. Thank you, everyone, for joining us. Unless Simme and Danielle, do you want to say any final words?
I would encourage Daniel to do some kind of plug regarding the project he's maintaining, and if
Yes.
people want to check that out and help with that.
Actually, I have something in mind that I might show internally. So maybe you will see something like that. Yeah.
Yeah, but you should at least plug what this awesome thing is that you're working on.
Ooh, so
Yeah,
I'm
just
working-
mention it.
Yeah.
I'm working on Tempo. Tempo is a distributed tracing backend from Grafana Labs. It's pretty cool because it tackles some of the difficulties that you might have while scaling Jagger. That is like the main open source project for distributed tracing. For example, it relies fully on object storage to store the traces. So it's really cheap. You don't have to maintain some kind of Elasticsearch or database. Yeah, it's a really fun project to use. So if someone watching this wants to try some distributed tracing project, go to
Actually,
the repo.
you should totally do a demo on office hours.
Ooh,
for that.
nice. I have one demo in mind for doing this with K6, so we can do something. Yeah.
No, I meant now. Just kidding.
Nicole.
I'm not prepared.
I know, that's why it's fun. This is a chaos experiment. You just failed.
I mean, Sime's ready.
Yeah,
Okay.
and it was really fun to have you on, Daniel, just as Nicole said. And thank you so much to everyone watching. And feel free to chime in with questions and thoughts and get in touch with us if you want to talk with us about anything we've said. Maybe you want to call us out on something we've said that is wrong, or you just want to collaborate or exchange ideas. We're always available. At least me and Nicole. I'm not
We'll
going to
drag
promise
Daniel
Daniel
in
as
too.
Sometimes, and sometimes available, but yeah, sure.
Yeah.
All right. Bye, everyone.
Bye.
Bye-bye.
Thanks.